All right, welcome back. This is the third lesson in the polynomial chapter. Yesterday or last time we were looking at the polynomial reviews from Math 9. Today, and at the end, we did multiplying binomial with a monomial or a monomial with a polynomial. Today, we're going to be looking at multiplying polynomials. Okay, so either binomial with a binomial, that's our first example, or it could be a binomial with a trinomial or more, right? It could be trinomial times trinomial. So anyways, just polynomials multiplied together. Now there are three different methods I'm going to show you. The first two are very much the same thing. The third one is a little bit different, okay? So let me show you the distributive method first, okay? So this one is basically the distributive property, but with one additional step, okay? Because it was only a monomial, okay? So first, times 2x with the 3x, you get 6x squared. And then you go negative 3 times 3x, which is negative 9x. Okay, so that would be finished if it was only a monomial. But because there's one extra term, so we have to multiply those two as well, right? So 2x times 1 is 2x. Negative 3 times 1 is minus 3. Okay, now you can see the middle two terms, those are like terms. We can combine them together. So we get 6x squared. That we cannot do anything about. But negative 9x plus 2x is minus 7x. And we still have minus 3 at the end. Okay, so that's the distributive method. Method number 2 is the horizontal method, we call this the foiling. Okay, this is how I learned it when I was in high school. Oh my gosh, almost 20 years ago. That's crazy. Anyways, so it's very similar to the first method. It's just the order in which we multiply is different, okay? So you start off with 2x times 3x. That's the f. First with the first, that's 6x squared. And O stands for outside, so you go 2x times 1, which is 2x. I stand for inside, so negative 3 times 3x, that's negative 9x. And L stand for last, so negative 3 times positive 1, negative 3. And you can see it almost yields the same thing, except the middle two terms are reversed in order, but really it's the same thing, okay? I don't know. Again, these two are pretty much the same thing. It's just the order in which you multiply is different. Okay, so either way, it's fine. Okay. The last one is a little bit different. This is the rectangle method. It's the area method. Okay, so I'll show you. So you can treat, here we are multiplying two expressions, right? So you can relate this to like area of a rectangle because that's how you multiply or how you get the area, right? It's multiplying the length with the width. So I'm going to split this into 2x minus 3 and then 3x plus 1, like that. Okay, so you have 2x times 3x, so that gives you this piece right here, 6x squared. You have the 3x times negative 3, which gives you the negative 9x right here. You have the 2x times the positive 1, which is 2x. You have the positive 1 times negative 3, which gives you that piece right there. Okay, so you can see this gives you the area of this rectangle. So the final expression is, well, then you just add them all together, right? So you have the 6x squared. And again, you have the 2x and the negative 9x. They are like terms, so you combine them together. And then you have the minus 3 at the end. Okay, so that's the rectangle method or the area method. And again, you can see, regardless of which method you use, you get the same result. So any method is okay. Okay, it doesn't really matter. Personally, well, again, this is the way I learn, so I'm just used to it. But both of these, or all of these three are perfectly okay, okay? All right, so there are two examples here. I will show you with, I will use a FOIL method for one, and I'll use the rectangle method for the other one, okay? So maybe I'll use the, I don't know. I'll just expand. I'll just use the FOIL method in this case, okay? So, in this case, it's more than just FOIL because FOIL is first, outside, inside, and last. But this one, you get more than just FOIL. But it's the same thing, okay? So you go x squared times 3x squared. That's 3x to the power of 4. Again, you add the exponents when the base are the same when you multiply. Then you go x squared times negative 4x, that's negative 4x cubed. You keep going, x squared times 3 is 3x squared. Now the first term is finished. Now you move on to the second term. So you go negative 3 times 3x squared, that's negative 9x squared. Negative 3 times negative 4x is plus 12x. Finally, negative 3 times positive 3 is negative 9. The reason why I like this method is because it kind of put the exponents in order like that. So then you don't really need to look for, because I think if you use the distributive method, I think the order might, I don't know. You know what? I'm not gonna say anything. That might not be true. Okay. Anyways, so if you collect like terms, you have two like terms here, namely these two. So you can write down the rest. But this one you gotta combine them. You get negative 6x squared, and the rest stays the same. Okay, and that's how you finish the question here. Okay. For the second example, a plus b squared, I will use the rectangle method or the area method. Now this one is actually just a perfect square, right? Because it's a plus b and also a plus b. So this is actually a square. Okay, because both sides have the same measurement. Okay, so a times a is a squared, a times b is ab, a times b is again ab, and b squared, or b times b is b squared. And therefore, if you multiply them together, oh, I shouldn't say equals there. I'll rewrite the question here. A plus b squared is then going to be a squared plus, you got ab and ab, so you have two of them, so 2ab plus b squared. Okay, so again, all these methods are valid. You just need to pick the ones that you prefer. Okay, so here's the example. Why don't you try it? It says calculate the area of the square shown on the right. So this has a side length of 4x plus 5, and you're supposed to find the area. So it's essentially what I just showed you with the area method, right? You can, again, it's gonna be length times width, because that's how you find the area. But because it's a square, the length and the width is the same. So the area is simply gonna be 4x plus 5 squared. Okay, so I'll pause here, or you should pause the video and try it. Again, pick whichever method you prefer. Okay, and I'll show you the answer in a bit. Okay, I will. You know what? Because the diagram is drawn already, I'll just use the boom, boom. Rewrite this as 4x and 5. Okay, use the area method. So you get 4x times 4x, 16x squared. 5 times 4x is 20x. We got 4x times 5, that's also 20x, and then 5 times 5 is 25, okay? So again, that's the reason why this is 4x times 4x is because that this length is 4x, and this length is also 4x, right? And this is 5, that's 4x, so to find the area of that rectangle, it's 5 times 4x, and so on. Anyways, so now we can combine like terms. So we have 16x squared. We have 20x here and 20x there. Combined together, that's 40x. And then we got a 25 here, and that's just 25. Okay, so that's how you find the area of a square, in this case, with an expression side length. Okay, the next example is about the volume. Okay, so recall, and it's a cube. So recall the volume. To find the volume, this is length times width times height. Now, because all the length and width and the height are the same, so this is just going to be x plus 2 times x plus 2 times x plus 2. Now, we're actually multiplying the binomial 3 times here. So quickly recall from last time, the way to do this is that you finish the first two first. Once you get a product of that, then you multiply the third set of brackets. Okay, so I'll show you in this case. This time I will use the FOIL method. So it's going to be x times x, x times 2, 2 times x, 2 times 2. And I'm just going to copy that down. Okay, and now from here we can combine. Actually, you know what? Before I move on. I should always have the unit, right? Unit squared, because it's area. Now it doesn't tell you if it's meters, centimeters, or whatnot, so I'm just gonna put unit squared. Okay, come back here. Now we're gonna collect like terms here. That's gonna be x squared plus 4x plus 4 times x plus 2. Okay, and now from here I can again distribute or FOIL. Either way, x squared times x is x cubed. X squared times 2 is 2x squared. You keep going with the next one. 4x times x is 4x squared. 4x times 2 is 8x. And I'm running out of room to draw the arrows, but that's okay. That's 4x, 4 times x, and then 4 times 2 is 8. Okay, you can see the order in which is written down is very nice, right? You have like terms here, and you got like terms here. So you just combine them together. 2 plus 4 is a 6. 8 plus 4 is 12. And then we got 8 there. And then the unit will be unit cubed. Okay, so that's how you find the volume. Again, when you have 3 set of brackets multiplied together, you just multiply the first 2 set of brackets, simplify that, and then you multiply with the last set of brackets. And you have 4 brackets, same thing, first 2, and then the first 2 with the third, and then finish that, you multiply that with the fourth, okay, and so on. Okay, so you can see clearly when we simplify algebraic expressions, it often involves grouping like terms, okay, like we did here. We combine like terms here, we combine like terms here, and we combine like terms here. So make sure you group the like terms together, okay? Make sure you combine them, okay? All right, so here are a couple of examples. I feel like you should be able to do these, okay? So again, what you want to do is you want to expand this, okay? Expand meaning you need to multiply it out, right? So you either FOIL, you use the area method, you use the distributive method, or whatnot. You get an expression and then combine the like terms with the last 2, okay? So I'll give you some time to do these 2, okay? So pause the video and finish them, and I'll show you how to do them in a second. Okay, so for this one, you expand. 2x times 4x is 8x squared. Again, I personally prefer the FOIL method because that's how I was taught, and so then I don't also need to draw the square. But you know what, or rectangle, if you prefer to draw rectangles, that's fine, that's perfectly okay. Anyways, when I expand, that's what I got, and I'm going to copy the last 2 terms now as well. Okay, now once I have everything written down, I can then look for my like terms. I have 8x squared, 10x squared as my like terms, so combine them together, I get 18x squared, and then we have the negative 10x, 12x, and the negative 3x. If you combine them, that's negative 10 plus 12, that's positive 2. 2 minus 3 is negative 1x, or just minus x, and we still have the minus 15. Okay, so that's how you simplify this right here for part A. As for part B, it's actually similar, but this is a square, so be careful whenever you have a square. This is the common mistake when people try to square the binomial. They just go 2q squared, 4, that's 4q squared, minus 3 squared is 9, right? They just try to square the individual terms. It unfortunately doesn't work that way, okay? I would suggest for now you write it out. Okay, 2q minus 3 squared, 2q minus 3 squared means 2q minus 3 times 2q minus 3. Okay, and then I'm just going to rewrite it. So I'll just work with one line in the next line here. Okay, and now I can distribute. That's 2q times 2q, 4q squared. 2q times negative 3, that's negative 6q. Negative 3 times 2q is again another negative 6q. I hope you start to notice something. Whenever you have a square, these two are the same. I don't know if you notice that. Here, you see, that's 20x, that's 20x. And that's AB, that's AB, okay? Keep that in mind, okay? Keep that in mind. Okay, come back here. Negative 3 times negative 3, that's a positive 9. I have a habit of put them in brackets. I think that's a good habit to have as well, especially when it's a subtraction. Okay, it actually it doesn't make a difference, but actually it does, especially for the second part. Okay, so I think for sure do it that way for now at least. Okay, then later on if you found out the pattern, then you don't have to anymore, but for now I think you should. Okay, and then for the next one we got 5q times 4q, that's gonna be 20q squared. 5q times -5 is -25q. 1 times 4q is positive 4q, and then 1 times -5 is just -5. Now we can combine like terms. Okay, so we got 4q squared minus 20q squared. That's going to be -16q squared. And like I said, these two are like terms. These two are also like terms. Here you combine together to be -12q. And here you get -21q when you combine them together. But be really careful. Again, this is why we put brackets. It's minus -21q. Recall, minus negative turns into a plus. So -12q plus 21q is actually positive 9q. Again, the reason why we turn it into a plus is because we have a minus sign here and a negative sign here. When you take away a negative number, it's actually adding the number, okay, adding the positive number. So it's -12q plus 21q, which gives you positive 9. Finally, we got 9, again, minus -5. So minus negative, again, turn into a plus. So that's 9 plus 5, which is 14. Okay, so be really careful with the minus sign here. That usually gets students. Okay, so just be really careful. All right, we got a couple more examples here. We're looking for the area or volume for the following questions here. It says the width of a deck that surrounds the square pool is 2 meters. So the width of the deck, so this is 2 meters and this is 2 meters. Assuming that the pool has the width of x. So this piece right here is x and that piece right here is x. It says write a simplified polynomial expression that represents the area of the deck. Well, we know to find the area of the deck, we simply take the larger square and take away the smaller square. Okay, now how do we find the area of the larger square? Well, that means we're gonna find out how long this is. Well, we know this is x, and the width here is 2, and the width here is 2. So in total, that's gonna be x plus 2, and then another 2. So in total, x plus 4. Similarly, for this portion, again, this piece is x, that's 2, and that's 2. So in total, that's also x plus 4. Okay, so to find the area of the deck, then you simply go x plus 4 squared. Again, that's the area of the entire pool with the deck. Take away the pool itself. That is x times x, right? So x squared, that's this area. Okay, so then that's a polynomial expression, but we want to simplify this, so we're gonna go ahead and multiply this out. So this is going to be x plus 4 times x plus 4 minus x squared. Okay, and now we can expand. That's x times x squared, x times 4, that's plus 4x. Again, this is a perfect square. You can see that's because it's x plus 4 and whole thing squared. Again, notice that pattern. The middle terms are identical, right? That's 4 times x, so that's 4x again. 4 times 4 is 16, and we still have the minus x squared. Now we combine like terms. That's x squared minus x squared, no more x squared. 4x added together, you got 8x plus 16. So that's the simplified expression of the area of the pool deck. Second part says, what's the area of the deck if the pool has an area of 49 square meters? Okay, well, if the pool has an area of 49 square meters, that means x squared equals 49. So we can quickly solve for x by taking the square root on both sides. So x equals 7 meters, right? You can simply plug in or square rooting both sides to get 7 for the x. Now, because this is the expression for the area of the deck, and we know that x is now 7, therefore the area of the deck is simply going to be 8x plus 16. And now we can plug in 7 into x. So that's going to be 56 plus 16, which is going to be 72 square meters. Okay. Okay, 8 times 7 is 56. 56 plus 16 is 72. Okay, finally, the last example. It says write an there's a typo here, not and. Write an expression for the volume of the following object. So you can see this is, we have 3 little cubes with side length of 2x minus 1. So again, to find the volume, you simply take the length times the width times the height. And again, this case, they're all the same because it's a cube. Now that's for one single cube, but we know we have 4 of them. So we are gonna put 4 in the front. So we can, because there are 4 of them. Okay, so now we can multiply this quite easily. First of all, I'm gonna distribute here. 4 times 2x is 8x times 1. 8x minus 4. So that's the first 2 terms multiplied together, and then we still have the 2x minus 1 and the 2x minus 1. And now I am going to distribute right here. That's 8x times 2x, which is 16x squared. 8x times negative 1, which is negative 8x. Negative 4 times 2x is negative 8x. Negative 4 times 1 is plus 4. And we're going to multiply that by 2x minus 1. But before that, we are going to combine like terms. This is going to be 16x squared. These two are like terms. That's negative 16x plus 4 times 2x minus 1. Okay, and now we can, again, multiply or distribute or FOIL, however you want to do it. That's 16x squared times 2x. That's 32x cubed. 16x squared times negative 1 is negative 16x squared. You continue here. Negative 16x times 2x is negative 32x squared. Negative 16x times negative 1 is plus 16x. I'm running out of room, so I'm going to continue with the next line here. That's 4 times 2x. That's plus 8x. 4 times negative 1. That's minus 4. And now we can combine like terms together. That's 32x cubed. These two are like terms. Negative 16 minus 32 is negative 48x squared. 16x plus 8x, that's plus 24x. And then minus 4. Again, unit cubed. All right, so that's how you multiply polynomials together. Again, there are 3 methods that I show you. The first 2, the FOIL method, the distributive method, they're essentially the same thing. It's just the order in which you multiply is different. So you can use that method or one of those 2, or the rectangle method or the area method, and they're all just as valid. Okay. Now you have some questions to practice. Let me know if you need some help. Okay. Good luck.